This is video tutorial number 7. We are going to go over finding the complete equation, which is sometimes also called the molecular equation, the complete ionic equation, and the net ionic equation. So for example, if we want to write those 3 types of reactions for when silver nitrate solution reacts with sodium chloride solution. The first thing we're going to need to do is figure out the formula for the silver nitrate and the sodium chloride. So silver has a charge of +1 and nitrate has a charge of -1. So when we crisscross and drop the signs, that becomes AgNO3, and that's aqueous because they said it was a solution. We're going to add that to sodium chloride, which is Na+1 and Cl-1. So again, those charges are same number, opposite sign, so they cancel out. And the formula for sodium chloride solution would be NaClAq. In order to find out our products, we do our inners, Na in front of NO3. Again, it was a +1 and a -1, so the formula is just NaNO3. This is aqueous because we said group 1 ions, nitrates, and things containing ammonium would automatically be soluble, so we're going to give this an aqueous. Then when we do our outers, our Ag in front of our Cl, that was also a +1 ion and a -1 ion, so they cancel out. This is going to get an S after it. It is a precipitate. It does not contain a group 1 metal. It does not contain nitrate, and it does not contain ammonium. So for our purposes, we are going to call this a solid or a precipitate, and it is insoluble. Now, to do this, put this into the complete ionic equation, we need to go back to the charges that we used when we crisscrossed. Anything that is aqueous, I should say, and ionic, will be broken up into its ions. So for the complete ionic equation, we're going to say Ag plus aqueous plus NO3 minus aqueous, we can't forget our charges, plus Na plus aqueous plus Cl minus aqueous. And again, we could put in +1s and -1s, or just simply the plus or the minus. That implies the 1. For the NaNO3, again, it's soluble, so we do Na plus NO3 minus aqueous. Remember, polyatomic ions do not get separated any further than into the polyatomic ion itself. And we're going to keep the AgCl combined. It's still solid, and it's combined because of the fact that it's the precipitate. The precipitate will not break down. Once we have our complete ionic equation, we look for things that are the same on each side. NO3 and NO3 look identical. Na and Na look identical. Therefore, those species will not drop down into the net ionic equation, and our net ionic equation will become AgAq plus Cl minus AQ yields AgCl solid. And this reaction is the one that tells us what's really happening and what's changing in solution. The ones that we got rid of from the complete ionic are called spectator ions.